We have a tank of water, and the tank is in the shape of a cone, and the base of the cone has a radius of 5 feet, and the height of the cone is 12 feet. And we want to find the work done in pumping the water over the top of the tank. And we'll make the assumption that that water weighs 62.5 pounds per cubic foot. And so for this problem, we'll place the y-axis right in the middle of the cone right here, and then the x-axis is right here. And so the bottom of the cone is at the origin right here. And if we slice the cone right here at a height of 5 feet, meaning the distance from here to here is 5 feet, and so we like to know what is the radius of the circle right here. And so here we have a right triangle, and this is 5, and this is 12. And then from here to here is 5, and then we want to know what is the radius of this circle, or what is x. And so what we have is this right triangle right here, which is this right triangle. And then we have x here, and then we have 5 here. So we have x, 5. And so the two right triangles, they are similar. And so because they are similar, we will have the ratio 5 over 12 will be equal to x over 5. Because this smaller right triangle is similar to this bigger right triangle. So we get 5 over 12 is equal to x over 5. And then cross multiply, then we get 12x is equal to 25, and then dividing both sides by 25, we get x to be 25 twelfths. And so this circle right here, which is 5 feet from the ground, the radius of the circle will be 25 over 12. And then here's another one. Suppose we slice the tank here at a height of 5 feet, and then we like to know what is the radius of this circle right here. And so again, this will be 5, and this will be 12, and then from here to here be 8, and then we're looking for x, which is the radius of this circle right here. So we get 5 over 12, and then x over 8. So we get 5 over 12 is equal to x over 8. And then cross multiply, 5 times 8 is 40, and then x times 12 is 12x. And so we get x is equal to 40 over 12. And so in general, if we have a cross section right here that is y feet from the ground, then the relationship between x and y will be 5 over 12 is equal to x over y. And then cross multiply, we get 12x is equal to 5y, and then dividing by 12, then we get x to be 5 over 12 times y. And so that's the relationship between x and y, where x is the radius of the circle that is y feet above the ground. And so what we're going to do is this, so we have a tank full of water, and so what we'll do is we'll slice this tank right here, we'll slice it into an infinite number of slices. And so this is one slice of water, and it's in the shape of a cylinder. And so let's find the weight of this slice of water. This is one slice out of an infinite number of slices. And so the weight of this disc, or of this slice of water, will be 62.5 pounds per cubic foot times the volume of the disc of the slice. The disc is in the shape of a cylinder, and therefore the volume of the disk is pi times the radius times the height of the disk. And then this disk has a radius. Yes, I didn't draw it. Radius of x is so the disk. This disk right here, the radius is x, and it's y feet from the ground. And so the radius right here will be x squared, and the height or the thickness of the disk will be some y distance, so we call it delta y. We have shown that x is equal to 5 over 12y. And so in the place of x, we have 5 over 12y. 5 over 12 y squared is 25 over 144. And then if we do 62.5 times 5 over 144 and then times pi, it will come out to be about 34.088. And then here we have y squared and then delta y, which is the thickness of this disk. And so now we want to find the work that's required to lift this disk of water to the top. Work is defined as 4 times distance. And so in this case, for this disk, the force needed will be the weight. The force is the weight of the disk. And so the force will be the weight of the disk, which is this expression right here. And then the distance for this to move this disk to the top, we will move it from here up to the top. The distance from here to here is y, and so the distance from here to here be 12 minus y. And that's why we have the distance is 12 minus y. And then simplify it a little bit. Y squared times 12 is 12y squared. And then y squared times y would be y to the third. And so this is the work for done in moving this disk of water to the top. But this is just only one disk. Here we have an infinite number of disks of water. And so to move an infinite number of disks of water, then we will find the work in moving each disk and then add all of that up, and then we'll get the total work that's needed to move all of the water out of the tank. And so since we slice this tank right here into an infinite number of slices, we will have an infinite number of disks. And so here we have I running from 1 to n, and n runs to infinity. And so this is the work that's required to move all of the water out of the tank. And so this becomes the definite integral from 0 to 12, since y ranges from 0 to 12. So from 0 to 12. And the antiderivative for 12y squared would be 4y to the third. And antiderivative for y to the third is y to the fourth, dividing by 4. And then we need to evaluate from 0 to 12. And so the upper limit of integration is 12. So in the place of y, we have 12. So we have 12 here and 12 here. The lower limit of integration is 0. So in the place of y, we have 0 and 0. So this part will become 0. And then if we simplify this part right here, it will come out to be 58,904.85 foot-pounds. And so this is the amount of work that's required to move all of the water out of the tank. So 58,904 4.86 foot-pounds.